A very good morning to all. Today let us see about hydrogen energy, how to generate and how to use it. So hydrogen energy refers to use of hydrogen as a fuel source for generating power. It is one form of cleanest and sustainable, which is reproducible and only leaves as a residue of water vapor after utilizing. There are different ways by which we can produce hydrogen. The methods are electrolysis, steam methane reforming, we call it as SRM, biomass gasification, and thermochemical process. Let us see one by one. The type of hydrogen produced is often categorized by the color code based on its environment impact. So when you generate hydrogen, you can generate by two ways. One is the power used for generation of hydrogen is from a conventional power source, which is from thermal power station or any other power station. That belongs to one type. And another one is generating this hydrogen from renewable energy source. So based upon this two, we have given the color code. Okay, so when you go by generating with renewable energy, we call it as green energy or green hydrogen, which is the cleanest form of hydrogen produced. Okay, whereas when you go for hydrogen from grid electricity, then we call it as a gray hydrogen or yellow hydrogen, which means you might have used some fossil fuels as a fuel for producing the power. In that case, that fossil fuel might have emitted carbon dioxide or any other gas that is going to pollute the environment. So the electricity used to generate hydrogen has induced some amount of pollution to this earth. So we call it as a gray or yellow. Whereas if that power is being taken from solar or wind, that doesn't polluted the earth, so we call it as green hydrogen. So these are the two types of hydrogen based upon the color. Okay, when advantage is by your solar or wind is zero emission, fully renewable if powered by clean electricity. So this is the overall setup of green hydrogen energy, where you can see here we have installed solar panel. So power from the solar panel is being taken. You can see the connecting wires that is being converted here. Now this is the electrolyzed tank, which will have a water, and there will be a two type of electrode again. So here we have shown it as clear. So you have a water tank. From the water tank, I am going to give it to electrolyzer. You can see there will be an anode and cathode. So this anode and cathode requires a supply to split this water into hydrogen and oxygen. This supply is given from solar. So this setup is called green hydrogen. So once you supply electrode with voltage, automatically what happens is hydrogen and oxygen get separated. You will get it as a compressor unit, where I will compress it and store it in the form of liquid. Both hydrogen and oxygen, I will compress it and I will use it for compress it and make it as a liquid, and I will store it. So whenever you want from this, you can take it. This reaction takes place in a unit called electrolyzer. Based on the type of electrolyzer and the operating condition, we can further classify or subdivision of types of electrolyzer. That is what this portion alone. Remaining is nothing but you are going to store it and you are get the power alone. So this is the place where it is going to hydrogen and oxygen get to be separated, that we call it as electrolyzer. There are two types of electrolyzer. One is alkaline water electrolyzer, another one is an high temperature solid state electrolyzer. So under alkaline water electrolyzer, the water is added with some alkaline material. Some alkaline material is nothing but salt. When you take a pure distilled water, then the ionization will not take place, that is separation of hydrogen and oxygen will not be there. So you add some salt. So adding that salt will try to create conduction in water, thereby the water get separated into hydrogen and oxygen. So when you give a supply to this anode and cathode, anode will be given positive as well as cathode will be given negative. Automatically once the supply is given, oxygen will be get liberated on anode side and hydrogen will be liberated on cathode side. We will have a collector, so there I will collect this gas and then I will store it. Whereas when you go for solid oxide electrolysis, a small difference, just not by pouring water alone, you try to pass steam. Okay, so typically the solid oxide electrolysis operate with a water in the form of steam at high temperature of 500 to 850, can drastically reduce the power consumption to split the water. So this power consumption will get reduced. When you go by the normal water, you need high required of power, whereas when you come to this method, the water requirement will come down, the power requirement will come down, thereby the power used to separate hydrogen and oxygen will get reduced. So this how to get steam is, wherever you might have used some application where you want heat, from that heat exhaust I can use that exhaust heat to boil this water to form a steam. Or you can even put a solar collector and try to focus sunlight on the water, thereby the water gets heated up and that heated water steam can be brought in. Okay, due to insufficient long-term stability, the technology has not been approached for commercialization. Here there are some issues with respect to handling the steam, so this has not been commercialized, this solid oxide electrolysis. Then comes steam methane reforming. So this is the second form of producing hydrogen. Till now what we have seen is, we have seen electrolysis. In electrolysis, the electrolyzer is subdivided into two types. Now let us move on to the next one, is steam methane reforming. So in steam methane reforming, what we do is a chemical process that use high temperature steam to produce hydrogen from methane. So what and all we require is, we require methane and we require steam. It's the primary industrial method for hydrogen production. This is how we try to produce. Now you should have a doubt why we go for methane. Why suddenly methane is brought here is, the reason is the method for production of methane is again a green energy process, where the industrial waste, house waste, then cow dung, all that is being used in biomass, thereby you decompose and try to get methane. So that is the way by which we try to get methane, and that is why we call it as methane is being generated by green energy. So the person who is being generated by green energy is brought here, and then from which we are going to take hydrogen. So again hydrogen generation will become a green hydrogen. Okay, so methane, which is nothing but CH4 from natural gas, is mixed with steam at very high temperature of around 700 to 1000 degree. This is how what you have to remember, and the pressure is between 3 to 25 bar. This mixture passes over a catalyst such as nickel. We will place a nickel and try to pass. Once this hits the nickel, the reaction produce H2, carbon monoxide and carbon dioxide. The carbon monoxide is removed in a water shift reactor with more steam to produce additional hydrogen and carbon dioxide. So when you pass this carbon monoxide with the water, again in water you will have hydrogen. That hydrogen is being liberated and this carbon will try to form carbon dioxide. The carbon dioxide is moved by pressure swing absorption as a acoustic absorption gas scrubber. So thereby what I will do is, I will try to deposit this carbon and then I will scrub it and I will use it the carbon for some other purpose. So nothing we have sent it to environment to pollute. Entire reaction, whatever I am getting, I am try to use it. So you can see here three things you are getting. when by this process. One is hydrogen, carbon monoxide and carbon dioxide. And with respect to carbon monoxide, we are very clear. Take this carbon monoxide, pass with steam, and then try to again observe the hydrogen from the water and try to make this carbon monoxide as a carbon dioxide. Now the observed carbon dioxide from here and this liberated carbon dioxide, we try to remove oxygen and leave this oxygen to environment, and this carbon we will try to deposit and try to scrub it and use it for carbon, which is used for so many applications. Then comes steam methane, just a diagrammatical representation. Okay, you will get steam, you preheat, then reforming reactor, there it liberates CO2. This CO2 again we will take into picture, then we will go to shift register and shift reactors and try to observe hydrogen. That hydrogen has been stored. This carbon dioxide again brought in, we are allowing with the steam and try to, what we have to do, we try to remove oxygen, and carbon we try to separately use it. Then comes the third method, which is biomass gasification. So where what we have seen here is, we take methane, okay, that methane can be from any natural gas placed on the earth surface, whereas here it is only from your waste. Okay, so gasification is a thermochemical process that converts biomass into mixture of gas known as syngas, and by heating this in the absence of oxygen with a limited amount of oxygen, we try to get hydrogen. This syngas can then be used to heat, power generation, or as a feedstock for producing other fuels and chemicals. So here we have drying. First process is drying. So we try to dry, then we try to get it with the charcoal, then we will try to combust it, then we try to do reduction process. Here little bit of oxygen will be provided, here no oxygen will be provided, that will liberate H2 and CO. Then geothermal process is similarly same as what we are doing. Only thing is, at initial heat which is we are getting from sun, so we try to get it from sun. So concentrated solar collector we will use. This solar collector will try to heat, so inlet receiving point for heat exchanger. So this will try to focus and try to focus the heat here. Once heat is here, you get a Kelvin I heat exchanger unit, the liquid of CaOH2. From this we will get H2 separately, O2 separately, and water. So this is called thermochemical process. Okay, so with this we will stop our discussion with respect to generation of hydrogen, that is green hydrogen. Thank you.